So we're in section 2.3. And we're going to learn how to divide polynomials. And we'll talk about the procedure, and then at the end we'll say why we want to do it. So we're going to talk about dividing polynomials, and then we'll learn for certain kinds we'll have a shortcut that's called synthetic division. And when we can use synthetic division, it's pretty nice. So let's review really quickly how we do long division, because that's what we're doing today. So let's take a quick detour. Let's say we want to do 7,213, and we want to divide that by 61. Let's remember how we do just our process for doing long division. So we're dividing this 4-digit number by this 2-digit number. Our first step, we say, how many times does 6 go into 7? 6 goes into 7 one time, and we put our 1 up here above the 2. And then we multiply. 61 times 1 is 61. And then we subtract. So 72 minus 61 is 11. And then we bring down the 1. And we do the same thing again. How many times does 6 go into 11? It goes in 1 time. And then we multiply. 61 times 1 is 61. And then we subtract. 111 minus 61 is 50. And we bring down 3. Now we say, how many times does 6 go into 5? 6 doesn't go into 5, so we say, how many times does 6 go into 50? 6 times 8 is 48, so 6 goes into 50 8 times. And then we multiply again. 61 times 8 is 488. Then we subtract, and we get 15. 15 is less than 61, so we can't do our division anymore. So our remainder is 15. And we can write, this tells us that 7213 divided by 61 is 118 plus 15 over 61. That's what this whole division process tells us. We're going to do the same thing with polynomials. We use the exact same long division process, but we're dividing polynomials instead of numbers. So let's look at an example of how we're going to divide two polynomials. Everybody, this bring back memories doing long division? So we're doing the exact same thing with polynomials. So let's look at an example to see the process. We want to figure out what we want to divide 2x cubed minus 5x squared plus x minus 8 and we're dividing that by x minus 3. So we do this, we set it up the same way. I'm going to put 2x cubed minus 5x plus x minus 8, 5x squared, sorry. And I put the x minus 3 out here and my division bracket here. And I ran out of room here, so let me do this. And I'm going to write this just so I have enough room. And all that's divided by x minus 3. All right, so we go about it the same way. We say, what do I have to multiply x by to get 2x cubed? 2x squared. So I'm going to write that up here, 2x squared. I write it in the second place over. Now I'm going to multiply. 2x squared times x is 2x cubed, and 2x squared times minus 3 is minus 6x squared. And I draw my line, and this is where people make a mistake. Remember, we're subtracting. We're subtracting all of this. So 2x cubed minus 2x cubed is 0, and negative 5x squared minus negative 6x is positive 1x squared. Negative 5 minus a negative 6 is the same as negative 5 plus 6. So I get x squared, and I bring down the x. What do I have to multiply x by to get x squared? X. So I'm going to put plus x up here, and then I'm going to multiply. X times minus 3 is minus 3x, and x times x squared is, x times x is x squared. And remember, I need to subtract. X squared minus x squared is 0, and x minus negative 3x? 4x. X minus negative 3. So 1 minus negative 3, so I get 4x, and I bring the 8 down, the minus 8. What do I have to multiply x by to get 4x? 4. So I write the 4 up here. Multiply. Negative 3 times 4 is negative 12, and 4 times x is 4x. And I'm subtracting. 4x minus 4x is 0, and 8 minus negative 12? 4. And now I can't divide x minus 3 into 4, so 4 is my remainder. So this tells me that 2x cubed minus 5x squared plus x minus 8 divided by x minus 3 equals what I have up here, 2x squared plus x plus 4 plus 4 over x minus 3. So it's the exact same process. Now, just so we have some terminology clear, we call this part the dividend. We call the part that we're dividing by the divisor, and the 4 is our remainder. So what this leads us to, and what we're doing here, is called the division algorithm. And what the division algorithm tells us is that, before we do this, any questions on what we did here for this long division? The process is exactly like long division for numbers. The important thing to remember here is we're subtracting in these intermediate steps. All right, so the division algorithm says that if we divide some function f of x by d of x, where we're not dividing by 0, so d of x doesn't equal 0, then we can find and by find is how we're dividing, is how we find them. We can find polynomials Q of x and R of x such that f of x divided by d of x equals q of x plus r of x over d of x. And that's what we did up here at the top. We said that f of x was 2x cubed minus 5x squared plus x minus 8 divided by x minus 3. So that's what we have here. Is q of x some function 2x squared plus x plus 4 plus our remainder, which is 4. And sometimes our remainder might be a function of x divided by our divisor. And again, f of x we call is the dividend. D of x is the divisor. Q of x is our quotient. And R of x is our remainder. Just so we're clear when the book uses the certain terminology. And the way we wrote the division algorithm here is equivalent to, if I multiply both sides by d of x, by our divisor, if I multiply both sides of my equation, I can rewrite this as f of x equals d of x times q of x plus r of x. These are the same thing. And we'll at the end when we do a little more practice, we'll talk about why we want to do this, why we want to divide polynomials. Let's take another look at a long division example, and then we'll talk about synthetic division. Synthetic division is a shortcut that makes long division a little easier in certain cases. So here's our example. We want to divide 3x to the third minus x squared plus 2x minus 3 by x minus 2. And we're going to use long division, so let's write out our 3x to the third minus x squared plus 2x minus 3. Oops. And we put our divisor out front. All right, so let's start. What do we have to multiply x by to get 3x cubed? 3x squared. And I put that here, and then I multiply. So 3x squared times negative 2 is minus 6x squared. 3x squared times x is 3x cubed. And remember, I'm going to subtract here. So 3x squared minus 3x, or 3x cubed minus 3x cubed is 0. Minus x squared minus negative 6x squared, 5x squared. Bring down the plus 2x. Now I say, what do I have to multiply x by to get 5x squared? So I have to multiply by 5x. So I write that up top. Now I multiply. 5x times negative 2 is negative 10x, and 5x times x is 5x squared. Subtract. Minus, or 2x minus negative 10x, 12x. Bring down the minus 3. What do I have to multiply x by to get 12x? Plus 12. Multiply, so 12 times minus 2 is minus 24, and I get 12x here. Subtract. And I get 12x minus 12x is 0. Minus 3 minus negative 24 is 21. So this problem tells us that 3x squared minus 3x cubed minus x squared plus 2x minus 3 divided by x minus 2 is 3x squared plus 5x plus 12 plus 21 over x minus 2. And if I rewrote it, if I rewrote this the second way we wrote it in our division algorithm, I could say that 3x cubed minus x squared plus 2x minus 3 equals x minus 2 times 3x squared plus 5x plus 12 plus 21. That's the second way we wrote it in our division algorithm. So this kind of gives us a picture as to why we might want to divide polynomials. Because what I've done is I started with a cubic polynomial here, and now I have a first degree polynomial times a quadratic. So this is the first step in factoring this equation. If we wanted to factor this equation and come up with all of our factors to find our zeros, find our solutions, long division is one way we could do it. So this gets us one step towards factoring our equation. If we choose the right divisor, we're on our way to factoring this polynomial. Questions before we move on? All right, let's look at synthetic division. Synthetic division is a nice shortcut to the long division algorithm. We'll need to know how to do both. The long division, you'll need to know how to do long division. Synthetic division only works in certain cases. So let's take a look at how we do synthetic division. And it's kind of nice the way it works out. So we're going to rework the same problem that we just did using synthetic division. So we can see how we set it up. So our problem was we had 3x to the third minus x squared plus 2x minus 3, and we were dividing that by x minus 2. Now the first thing to remember is synthetic division only works for dividing by something in the form x minus k. So synthetic division only works when we are dividing by a linear divisor. So it has to be in the form x minus k. That's the one drawback of synthetic division. It only works in this special case. But we're often interested in dividing by something in this form, so synthetic division is a great tool. So in our example, we have x minus 2. So in our example, k equals 2. Notice this is like when we talked about vertex form, or when we talked about the coordinates of the center of a circle. We have to write it as x minus something. and the thing that we have here is opposite in sign to what we have here. So we have x minus 2, so k equals 2. So for synthetic division, all I write down is the coefficients of my dividend. And I need to write them in descending order of powers. So I need to write my dividend in so that my powers go in descending order. Here I have cubed, squared, 1, first power, and 0 power. So my problem is set up that way already. So I'm going to write 3, negative 1, 2, negative 3. And then I'm going to make my division bracket kind of upside down. Out front here, I'm going to write just k. Whatever my x minus k is, I'm going to write k out front here. And my first step is to bring this number down. Now here's where synthetic division is nice. 2 times 3 is 6. I put the 6 here. Now I just add negative 6 plus 1. Negative 1 plus 6 is 5. Now I multiply the 2 times 5, and I get 10, and I put the 10 here. And then I add. 2 and 10 is 12. Now I multiply the 2 times 12, and I get 24. Put that here. Add these two. I get 21. I started with, in this problem I had x cubed, so my power is going to be reduced. So this is my x squared. This is my x, this is my constant, and this is my remainder. So my answer is 3x squared plus 5x plus 12 plus 21 over x minus 2. Much quicker, yes? Yes?
Are there times where you have to find all the zeros and so you have multiple answers for where it's leading?
Yes. So that's where we're leading to. Is if we know a couple of the zeros of the function, we can find the rest of them using division. And we'll get to that in just a second. We'll do one more example of synthetic division, and then we'll talk about why we want to use it. Okay? Any questions on how we set the synthetic division up? And the reason that we set it up the way we do, the reason that here we have minus 2 when we put a positive 2 here, is that's what lets us add here instead of subtracting. When we do long division, we have to subtract. When we do synthetic division, we can just add. And that makes it a little easier to do. So let's look at one more example of synthetic division, and then we'll talk about why we want to use it. So let's say we have negative 2x squared minus x plus 4x to the fourth plus 1. And we want to divide that by x plus 2. Now our first step is we want our polynomial in descending powers. So we want the highest power first and go in order from that. So I'm going to rearrange this. I have to, in order to use long division and in order to use synthetic division, I have to rearrange in descending powers. And I also have to be careful if there's one of the powers missing. So I'm going to rewrite this as 4x to the fourth. How many x cubes do we have? 0. So I'm going to write plus 0 x cubed, because we need to account for that one. Minus 2 x squared minus x plus 1. So there's my polynomial written in descending powers. Now we'll set up our synthetic division. So I'm going to write 4, 0, -2, -1, 1. And here I can rewrite this as x minus -2. So k is -2. I'm going to put a -2 out here. My first step, bring the 4 down. -2 times 4 is -8. Add these. 0 plus -8 is -8. -2 times -8 is positive 16. Add these two. -2 plus 16 is 14. Multiply these two. -2 times 14 is -28. Add. I get -29. And multiply these two. -2 times 29 is 58. Add these two, and I get 59. So my answer is, I started with x to the 4th, so I'm going to reduce the power by 1. I get 4x cubed minus 8x squared plus 14x minus 29 plus 59 over x plus 2. Pretty nice, huh? Any questions on how we do synthetic division? So a good part of the homework tonight is just going to be practicing doing this synthetic division and doing the long division. Remember to write your problem, write your polynomial in decreasing powers, and synthetic division only works when we have x minus k. So the reason that we want to divide polynomials, we have a couple. We have the remainder theorem and the factor theorem. So the remainder theorem, and this is one place where division is really nice. The remainder theorem tells us that if we divide f of x by x minus k, the remainder R is f of k. So let's say we have a really complicated polynomial, and we want to evaluate that polynomial at some number, and we want to get an idea of that value without using our calculator, without plugging it into our calculator. And say we have a really long polynomial, so plugging in, squaring, cubing, raising it to the 5th power is a lot of work. In order to find the value of k, all we have to do is divide our function by x minus k. So as an example of that, let's say we have f of x equals x cubed minus 2x squared minus 4x plus 1. And we want to find f of 1. Now we could plug it in and calculate, but we want to find f of 1 using the remainder theorem. So to find f of 1 using the remainder theorem, I'm going to divide by x minus 1. And the remainder will be f of 1. So let's set up our synthetic division. We have it in decreasing powers. Synthetic division, let's just do this really quick. So I have 1, negative 2, negative 4, 1. Here k is 1. So I bring down the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 here. Negative 5. 1 times negative 5 is negative 5. Add those, and I get negative 4. So f of 1 negative 4 is our remainder. So f of 1 equals negative 4. That's what the remainder theorem tells us.
But that's just to like find the remainder.
Right. So this.
The numbers in synthetic division don't mean anything.
Nope. All we're interested in, if we're looking at the value of the function, is the remainder.
So those aren't like the numbers for the rest of the equation.
These would be the numbers. So if I divided it, this would be x squared minus x minus 5. And our remainder minus 4 over x minus 1. But the remainder gives us the value of the function at x equals 1. Now the special case, and this is what Cedric was asking about earlier, is our factor theorem. And our factor theorem is when the remainder is 0. The factor theorem tells us that f of x has a factor, x minus k, if and only if f of k equals 0. And we talked about this earlier. Well, what this tells us, we talked about this on Friday, factor, solution, 0, and x-intercept all mean the same thing. So if f of k is 0, this means that if we divide f by x minus k, the remainder is 0 if we divide f by x minus k. So that means if we know a factor, if we know a solution to our equation, if we know one factor, we can divide by x minus that solution, x minus k, and our remainder is going to be 0. This is how we can use long division to factor complicated polynomials if we know one or more of the solutions. So the way we would use this, a problem that uses the factor theorem is going to ask us, and there are a couple like this on the homework, is we have f of x equals 3x cubed plus 2x squared minus 19x plus 6. And the problem will ask us to verify that x plus 3 and x minus 2 are factors, and write the factorization of f. And factorization just means we want to factor it completely. So when we factor a quadratic, we have two parentheses multiplied by each other. When we factor a third degree polynomial, we're going to have three parentheses multiplying each other. Fourth degree, we're going to have four parentheses multiplying each other. So we want to write this as a set of parentheses, x plus 3, x minus 2, multiplied all together, that when we multiply them together, we get our original function. So to verify that these are factors, we're going to divide and show that the remainder is 0. So that's how you verify that there are factors. We're going to divide, and the remainder equals 0 if we have a factor. So let's set up our synthetic division. We have decreasing powers of x. So I'm going to write 3, 2, minus 19, and 6. We're going to start with x minus 3. I'm sorry, x plus 3. So k equals minus 3. Bring the 3 down. Negative 3 times 3 is 9. Negative 9, sorry. 2 minus 9 is negative 7. Negative 3 times negative 7 is 21. Add these, so I get 2. Negative 3 times 2 is 6. And my remainder is 0. So that shows that x plus 3 is a factor of this polynomial.
Can you leave that up, please?
Uh-huh. Now, just like when we factor, think about when we factor a number. We want to figure out what, if I wanted to factor 36. If I knew that 2, if I could divide 36 by 2, and I divide 36 by 2 and I get, what? 18. If I divide 36 by 2, I can divide then 18 by 3. I can divide in any order. So what I do next is I don't start over with my original polynomial and divide by x minus 2. I divide what I have left by x minus 2. Because if I divide something out of there, if this is a factor, it's still going to divide it. Just like if I divide 36 by 2, I can still divide 36 by 3, or I can divide 36 by 3 and then divide the second factor by 2. It doesn't matter which order I do it in. So I'm going to write this, my new polynomial is 3x squared minus 7x plus 2. And I'm going to divide this by x minus 2. If this is a factor of the original, it's going to be a factor of this also. So I'm going to say 3 minus 7 and 2. And here k equals 2. So 3 times 2 is 6. Negative 7 plus 6 is negative 1. And I get 2. And my remainder is 0. So this shows that x minus 2 is also a factor. And what do I have left? I started with 3x squared minus 7x plus 2. So this tells me I have 3x minus 1 left. So my factorization is all my three factors multiplied together. So f of x equals 3x minus 1 times x minus 2 times x plus 3. Yeah, Cedric.
How would you know whether to start with the x plus 3 or the x minus 1?
Doesn't matter. You can start with either one. If they're factors, you'll get a remainder of 0 both times. If you don't get a remainder of 0, that means it's not a factor. So the problems in your homework, you have a couple of these. They'll give you a couple of factors. They'll give you a couple of solutions. You'll graph the function in your calculator, find the intercepts. Some way or another, you'll figure out a couple of things that you need to divide by. And that will tell you how to set up your synthetic division, and you just keep going until you finish.
So you don't divide that out, you just leave it like that.
This was called the factorization of f. All right, homework. There you go.
The 65 or 63?
That's 65.